Okay, the first problem, which will be POW 21 for Math 8, is you needed to figure out what the value of x would be. You need to remember that whenever you have a triangle, all of the angles will always add up to be 180 degrees. The answer was x equals 20, and this is the way you get it. First, you're going to find the supplementary angle of 123. Right now on the inside of this triangle, we only have one of the angles that is known. So in order to find this one, its supplement is 123. Two supplementary angles add up to be 180. So we really just take 180 minus 123 and we get that that's 57. So this angle right inside here is 57 degrees. So now we know that one of the angles inside here is 67, the other one is 57, and when we add those two up, we get 123. Well, 180 minus 123 that we just found out is 57. So right in here, this is going to be 57 also. So now we need to set 3x minus 3 equal to 57. So done right there. And now we're going to move the 3 over here with the 57 by adding 3 to both sides. That will eliminate it from this side, and 57 plus 3 turns that into 60. And now we're left with 3x equals 60. Divide both sides by 3, and that's how you get x equals 20. Okay, the next problem, which will be number 22. This problem wanted you to find the distance that the airplane is from the airport. And this is a right triangle, and a right triangle, when we're trying to find the distance of either one of the legs or the hypotenuse, we would use the Pythagorean theorem. This answer ended up being C. If you did not get C, then you need to write down the steps I have over here. First, I started with the Pythagorean theorem, a squared plus b squared equals c squared. I knew what one of the legs was, so I just gave that the value of a, which was 4 squared. I don't know the next leg, so I'm just going to leave that as b squared. And the c squared, which is the hypotenuse, is 40 squared. So 4 squared is 16, b squared stays b squared, and 40 squared equals 1600. So I'm going to move this 16 over here with the 1600 by subtracting it from both sides. When I do that, I'm left with just b squared on the left-hand side, and 1600 minus 16 is 1584. Right now, I still do not have b by itself. It's a b squared, so we need to get rid of the squared. Well, the opposite of squaring something is taking the square root. So right here we need to take the square root of b squared, and whatever we do to one side of the equal sign, we need to do the other. So now we're going to take the square root of 1584. When we do that, we get b all by itself, and that equals 39.79, and which would round to 39.8, which was answer C. Okay, number 23. This one wants to know which value is equivalent to 4 squared times 4 to the negative 3. So we need to remember we don't want to have any negative exponents. And I came up with a little saying, like, when you change the sign, you must jump the line. So we want the 3 to be positive, so we're going to jump it to the bottom of the fraction. We're left with 4 squared on the top, 4 cubed on the bottom. Now it's positive. I wrote it out the long way. 4 squared really is 4 times 4. 4 cubed is 4 times 4 times 4. And we can reduce it that way. We can cancel out these two 4s. They turn into 1s. And what is left on the top is a 1. What's left on the bottom is a 4. So your answer was 1/4. Number 24. This question was a system of equations as shown, and then it wanted to know what was the y value to the solution in the system. And that answer ended up being D. What we needed to do was we needed to use the substitution method. Both of those equations, they were already in slope-intercept form, you could have graphed it on a calculator and then gone to the part where it tells you where they intersect. But another way to do it would be using the substitution method. So I did it that way to show you how to do it without a calculator if you weren't graphing it. So for substitution, since they're each equal to y, we have two equations that say y equals, one says 2x minus 1 and the other says 3x minus 3. So we're really just going to set them equal to each other. So when we have it right there, our next goal right now is just to combine like terms. So I moved the 2x from this side over to this side. I subtracted it from here. So I'm going to subtract it from this side. That leaves me with a negative 1 on the left-hand side. And over here, that leaves me with 1x. So I just wrote x minus 5. Now I'm going to move the 5 over to the other side to be with the 1. So the opposite of subtracting 5 is adding 5. So I'm going to add 5 to both sides. And 5 plus a negative 1 equals 4. And that leaves me with just x on this side. So x equals 4. They're not asking about x, though. They're asking about y. So what you want to do now is you want to plug it back into one of the original equations. Doesn't matter which one that you pick, just pick one of them. I happen to pick the first one, which said y equals 2x minus 1. So I substituted 4 in for x. 2 times 4 is 8. And then 8 minus 1 is 7. So y equals 7. If you picked C, you just stopped at the x. When the question was really asking you to find out what the y was. Okay, and the last one, which was POW number 25. It says line W is represented by the equation y equals x plus 3. And then it tells you that line Z is going to go through 2 points. One of them being 1, 0, and the other one 3, 4. It wants to know what their point of intersection is. Well, the answer on that one was C. It was at 5, 8. And the way you go about getting that is the first thing you do is you graph the equation, the first equation that it gave you, which was in slope-intercept form. You're always going to start where it crosses the y-axis, which was at 3. The slope of that equation was just 1. Remember, you find your slope right in front of the x. If there's not a number there, that means it's a 1. So we just went up 1 over 1, up 1 over 1. We continued with this pattern for a while. I also went down 1 over 1, down 1 over 1. And after I created that line, then I went ahead and I plotted the points from line Z. One of the points was at 1, 0, and the other one was at 3, 4. Right now, these have not intersected with line W. So I wanted to figure out the slope of these 2 points so I could continue on with more points. Well, remember to find the slope when you're given any 2 points. It's just, I did y2, I wrote y1 minus y2, but I really did y2 minus y1 all over x2 minus x1. Remember, you just need to be consistent with whatever you're choosing. So I did 4 minus 0 all over 3 minus 1, and I got 4 over 2, which reduced to 2. So the slope of that was 2. So what I did now is I just continued creating that second line with the slope of 2 until the 2 lines intersected. So I started right up here. My last one was at 0.34, so I went up 2 over 1. We still haven't intersected yet. Up 2 over 1. And right there is where they finally intersect, and that point is at 5, 8.